Hello everybody. This is day 2 of solving 3x3 systems, and what this is just a variety of different problems and then problems that have no solution or infinitely many solutions. So let's take a look at these and see how you do. So the first one here, again, like always, we're looking to eliminate one of the variables using all three equations. So I look at this first one and I say, I'm going to eliminate the y's. And the reason I'm going to eliminate the y's is if I add these two equations together, those will eliminate right away. Then, if I were to use the middle equation, I can actually use either one. So I'm going to go ahead and use the top one and the bottom one first. So I'm going to use these. I'm basically going to add those together. X plus y plus z equals 3. Then 3x minus y plus 2z equals 5. Now, I add these together. 4x plus 3z equals 8. So now, I'm going to work a little smarter, not harder here, and I'm going to use these two. So the top equation would stay the same. 4x plus 4y plus 4z equals 7. Then the bottom equation I'm going to go ahead and multiply everything by 4. Why am I going to do that? That would turn this into negative 4y. Now 4y minus 4y would be 0. That's exactly what I want. So 4 times 3x is 12x. 4 times negative y is minus 4y. Plus 8z equals 20. And now add these together. 16x plus 12z equals 27. Now, I'm going to take the two equations here, align them vertically, and solve this 2x2 system. Now, in order to get the variables to eliminate, I'm going to multiply this top equation. I'm going to choose negative 4 because that would turn this into negative 16x. Negative 16 plus 16 will give me that 0. So negative 16x, then negative 4 times 3z is minus 12z equals negative 32. The bottom one, 16x plus 12z equals 27. Right away, these add up to 0x. Look what happens here. This adds up to 0z equals negative 5. 0 times x is 0. 0 times z is 0. Does 0 equal negative 5? I have no variable to solve for. That's a false statement at the end. Since I can't solve for any variables, this would be no solution. Okay. Now this next equation, if I look here, I'm going to use these two, right? And then I'm going to use these two to eliminate the z's. These already add up to 0. These already add up to 0. So I'm just going to go ahead and add these equations together. So when I add these two equations together, this one becomes x plus y plus z equals 4. Then x plus y minus z equals 4. Add them together, 2x plus 2y equals 8. These eliminate. Now, if I add these two together, right away, if I add those together, x plus 3x is 4x, y plus 3y is 4y, z's eliminate equals 16. So now, if I take my two equations, 4x plus 4y equals 16, 2x plus 2y equals 8, right away, I know I'm going to multiply this bottom equation by negative 2. And the reason is that would create negative 4x here, and these would add up to 0. So the top equation stays the same. The bottom equation, I get negative 4x minus 4y equals negative 16. Now when I add these vertically, x's eliminate, and look what happens here. The y's eliminate, and I get 0 equals 0. So basically, up above, everything eliminated, nothing to solve for, but I ended up with a false statement at the end. What did that give me? No solution. Here, right, 0 equals 0, true statement, no variable to solve for. So this is infinitely many solutions. And if you look here, if I were to multiply everything in this equation, right, by 3, and then everything in this equation by 3, it would all pretty much match up. So the next, system, right, when you look at it, it actually works out really well because in this, it's 3 equations, but not every equation has 3 variables. So when I look at this, they already tell you what x is. So what I'm just going to do, anytime you get a problem like this, I look, all right, this only has x and y. Can I plug x in here? So that would give me 3x plus 4y equals 7. I'm going to replace x with negative 3. 3 times negative 3 plus 4y equals 7. Negative 9 plus 4y equals 7. Add 9. 4y equals 16. Divide by 4. Y is equal to 4. So right now, I know x equals negative 3. Y equals 4. All I have to do is find z. So all I have to do is take this equation now. I'm going to plug the variables, the value of the variables I know. Negative 2 times negative 3 minus 3 times 4 plus 5z equals 19. So 6 minus 12 plus 5z equals 19. This gives you negative 6 plus 5z equals 19. I'm going to add 6. 5z equals 25. Divide by 5. Z equals 5. So my ordered triple would be negative 3, 4, and 5. All right. Now the next example is a little uncomfortable, all right? But here's what we're going to do. If I look, the top equation has all 3 variables. The bottom or middle equation has x and y, and the bottom has x and z. So what I'm going to start out by is taking these 2 equations, and I'm going to eliminate, right, the y's. And you'll see what happens here. Okay, so the top equation is 2x minus 3. Oh, excuse me, let me just do this. I'm going to multiply everything in the top equation. I'm going to eliminate the y, so I want to make this a negative 6 and this a positive 6. So I'm going to multiply the top equation by 2. That would give me 4x minus 6y plus 4z equals negative 2. I'm going to multiply the middle equation, right, by 3. That would give me 3x plus 6y plus 0z, basically, because there's no z term. So I'm just going to put 0z equals 42. Now, when I add these together, 7x, the y's eliminate, plus 4z equals 40. So I'm going to take that equation now. And if I align the last equation right underneath it, what you see can happen is I can basically just solve this 2 by 2 system now. I used all 3 equations in the elimination process, so I'm good to go. So I'm going to multiply to solve this. Top equation is going to stay the same. The bottom equation, I'm going to multiply by negative 7. So negative 7x plus 35z equals 77. That would give me 39z equals 117. When I divide by 39, z equals 3. Now I can plug that back up here. X minus 5z equals negative 11. Replace z with 3, right? Then x minus 15 equals negative 11. Add the 15, x equals 4. Now, if I just take those two values, or basically the x value, and plug it in, x plus 2y equals 14. So if x is 4, right, subtract 4, 2y equals 10, y equals 5. And my ordered triple for the solution here would be x is 4, y is 5, z is 3. And I am done. The solution here, if you get the correct answer, you can go ahead and just fast forward to the next problem. Okay, the answer here is 2, 1, negative 4. So if you were able to solve this and get that answer, right, you can fast forward to the next problem. For this, I look and see that z is probably the easiest to eliminate here, right? So if I look, I'm going to use these two equations to eliminate z. So I'm going to multiply the top one by negative 2. That would give me negative 6x minus 4y minus 2z equals negative 8. The middle equation will stay the same. And that would give me negative 4x minus 7y equals negative 15. Now, what's nice is if I use the first and third equation, the z's already eliminate. So now 3x plus x, I'm just going to write it right underneath here. That would give you 4x. 2y plus 4y would give you, so I basically added these. I added these to get plus 6y, right? The z's add up to 0 equals 4 plus 10 is 14. What's even nicer here is if I take these two equations, the x's already add up to 0. They already eliminate. So that would give me negative 1y equals negative 1. Y is equal to positive 1. So now when I take this equation, 4x plus 6y equals 14, replace y with 1. 4x plus 6 times 1 is 14. 4x plus 6 is 14. Subtract 6. 4x equals 8. Divide by 4, x is equal to 2. And now I can go up here and find z. If x plus 4y minus z equals 10, I basically am using this equation, right? Replace x with 2 plus 4 times 1 is 4 minus z equals negative 10. 6 minus z equals negative 10. Subtract 6. Z equals 16. Ordered triple, x is 2, y is 1, z is 16. So for this last problem, I'm going to basically tell you the setup and then the solution, because I think by now you should be able to go through the solving process. But it says the marketing department of a company has a budget of $30,000 for advertising. A television ad costs $1,000, radio costs $200, newspaper ad costs $500. The department wants to run 60 ads per month and have as many radio ads as television and newspapers combined. So there's three things that they give us here. They tell us they have a budget of $30,000. They tell us the number of ads they want to run. And they also tell us the radio would have to equal this, television and newspapers combined. So if we start with just a number of ads they want to run, right? I'm going to let T equal television, right? R equal radio. and then I'm going to say N equals newspaper. For the number of ads, right, we know the number of television plus the number of radio plus the number of newspaper has to add up to 60 total ads. Now, when we talk about the budget, each television is $1,000. So 1,000 times the number of television ads plus 200 times the number of radio ads, because it's 200 for a radio, plus 500 times the number of newspaper ads. When I take the cost of the television, the cost of the radio, and the cost of the newspaper, that all has to add up to $30,000. Now last, they tell us the radio has to be equal to the television and newspaper combined. So we know the radio has to equal the television plus the newspaper combined. Now, all you're going to do now is just go ahead and solve this system. When you solve this system, okay, you should get I believe you would get television equals 18, radio equals 30, and newspaper equals 12. Just a hint of advice when you're solving this. I would take this equation, R equals T plus N, and I would basically move the T over by subtracting T, move the N over by subtracting N, so I would have R minus N minus T equals 0. Or if I wanted to match it up above with the first equation, right, I would do negative T plus R minus N equals 0, right? So rewriting that bottom equation like that would help. Go ahead, try the homework, and let us know if you have any questions.